For this function, we're going to put together all that we know about transformations in order to graph the final function. So recognizing the parent graph first. So if you look through here, what I want to notice is that at some point we have the x value that gets squared. So this is going to mimic the graph x squared. Y is equal to x squared, which is a parabola at the point 0, 0. So then we can go through and look at all the different pieces of the function and try to figure out how that translates into the actual graph. So the first thing I might notice is this negative. So there's a negative in front or outside of that squared piece. So when we talk about inside or outside the function, it all has to do with that parent graph. So our parent graph is sort of x squared. And since the negative is on the outside of that squared piece, it's going to flip or rotate along the x-axis. So that would make a graph look something like this, because that's what the negative x squared graph would look like. So then if we move through, we see that we have a plus 3. But we have a plus 3, and that would be considered, inside the function. So we have an inside, a plus 3. So it's inside because based on that squared piece, the plus 3 is inside the portion that's squared. So that means we would have to move either to the left or to the right. Anytime it's positive, you're going to move to the left. And then finally, the last piece that we have is the plus 8. The plus 8 would be considered to be outside the function. So anytime you have it outside, so it's outside of the squared piece, it's going to move up or down. So anytime it's positive, it's going to move up. So this tells us we're going to move up 8 units. So you can, if you wanted to, each step, we could go ahead and construct the graph. So I did that for x squared, negative x squared. I could do the same thing. I guess I could sort of squeeze it in there in green. The same thing when we moved it to the left 3. So if I took negative x squared and moved it to the left 3, I'd have 1, I can't really squeeze it very well, 1, 2, 3, and that would be sort of our starting point, and then it would still be in the downward direction. And then finally we would take that graph and move it up 8 units. So let's go to our final graph. So normally you start at 0, 0 if you were going to do it all together. Flipping is not going to change that point 0, 0, but it is going to change the fact that the graph is going to go downwards instead of upwards. But then I do have to move left 3 and up 8, which would be right about here. And so now I just have to graph the downward shaping parabola. You can always find a few more points. Just to get a better idea of the graph. So in this case, if I had actually plugged in a negative 2, we should get 7. If I plug in 4, we should get 7. And you could find more points. I'm just going to at least try to draw a sketch of the graph just based on the transformations. And actually, by 4, I mean negative 4, because we're dealing with the point negative 4, 7. And that's our final graph.